Okay, so today we're going to talk about function notation and evaluating functions. Here's what function notation is. It literally will just tell you that the function evaluated at x, so meaning that variable, is this. So this little symbol is called function notation. It's just telling you that this thing right here is a function. And we'll talk about what functions are later in this chapter. But the first thing we're going to worry about is how to evaluate these things. So let's say I've been given the problem f of 5. So here's what that's saying. Instead of writing x, I'm going to write 5. So I'm going to plug in everything and see what I get. I'm going to come over here, go 2, 5 plus 5 minus 7. So I've now plugged that in. After plugging in that 5, whoops, forgot my other absolute value sign, we'll just go order of operations. So first thing, do what's inside the parentheses or absolute value. So that would be 10 minus 7. Then the absolute value of 10 would be 10. And that would be 20 minus 7, or my final answer would be 3. So again, function notation just tells you to take the number that you have and plug it into your function. Let's look at another example. Okay, so my next example, we again have function notation, so it's saying f of x is equal to 3x squared plus 2x plus 5. And this time, instead of plugging in just a regular number, we have a plus 2. So I'm going to go back to the original equation, and anywhere I see an x, I'm going to write a plus 2. And we've technically evaluated, but we haven't simplified it. So we're going to have to simplify this thing. So a couple things we're going to have to do. First thing, we'll have to take this and distribute it to each of those things. And then we're going to have to deal with the squared. So let's deal with the squared first. So here's my new equation of 3a plus 2 times a plus 2. When I distribute this, I should get plus 2a plus 4 plus 5. My next line would give me, let's choose a little bit of a darker color. Well now, since we have this kind of thing, because squared means times it by itself, so we have this kind of thing, we're going to have to double distribute. So I'll have to distribute the a, then I'll have to distribute the 2 to both things. So I'll have 3 times a squared plus 2a. So that was my a's going across. Now let's go with my numbers across. Plus 2a plus 4. Then if we simplify this backside, we'll get plus 2a plus 9. Now we have one last distribution. It's going to be the 3 over everything. So I'll have 3a squared plus 6a plus 6a plus 12 plus 2a plus 9. And then my very, very last thing when I simplify everything is I will combine all the a's, which I'll have 14 a's. I'll have 3a squared, and I'll have 12 and 9, which would give me 21. So that's how I would evaluate an equation or evaluate a function when I was given variables. One more thing we're going to go over, which is piecewise functions. Okay, so here's my first piecewise function. And as you can see for this piecewise function, you've got two different lines now. I have a top line and a bottom line. So here's what this thing is saying. It's saying that if x is bigger than 4, then I'll use this top spot. So that's why I have this, like, it's called a parameter up here when it's saying whenever x is bigger than 4 or equal to 4, you get 2. Whenever it is less than 4, though, I get this bottom line, which says it's x plus 5. So let's do our best to try to figure out what kind of answers we'll get. So I look at what I'm trying to plug in. I'm trying to plug in 6. And I go, okay, 6 is bigger than 4. So what spits out is 2. And that's my answer. Then I'll look at this one. It says f is 4. Now this one's a little bit trickier because I got to look where or what I'm going to get. So this one says f is 4. So I go, okay. This one isn't equal to, but this top one is. So since this top one is, again, I get 2. Now my next one says f is 2. Well, if f is 2, that means it's less than 4, which means I get this bottom one. So I will plug 2 into this bottom function. So 2 plus 5, or this would give me 7. For the piecewise function, you just got to make sure that when you plug the number in, you're picking the right one to plug it into. And in this one, the reason we didn't have to plug anything in is because it just said the number's 2. Like whatever you put in, you just get 2 out. This one, I actually have an equation, and so I have to plug in the number in for the x. Okay, the last part of this thing is graphing. And so as you can see, I have this function f of x, and it equals the piecewise functions just like we had before. And we're going to graph this thing. Now whenever you graph these piecewise functions, the most important point to start with is 2, or whatever the parameters have over here. So for this case it's 2, but whatever the parameters or the breaking point is, that's where I'm going to start. And I'm going to plug both into the equation, even though we don't get to include both. The only one I really get to include is this one. So I'm going to start out, and I'm going to say, okay, when x is 2, then that would make this thing 7. So I'm going to go over to 2 and up to 1, 2, 3, 4, 5, 6, 7. So I'm going to make that a filled-in dot, because right there, that's the point. Now this one I really don't get to include. It's not a real one because when x is 2, I don't really have it. But I want an end point for where my graph is going to be. So when I plug this in, I get 4, and 4 minus 1 is 3. So I'm going to go up to 1, 2, 3. I'm going to put an open dot because I really don't going to include that. Now I'm going to continue to graph these lines. So this one, since it has to be all the points that are less than 2, I'm going to go backwards. So I'm going to go 2 and over, 2 and over. And so this line is going backwards. It can't go forwards because it's less than 2. This line, since it's bigger than 2, gets to go forwards, and its slope is just 1 over 1. So I'm just going to go up 1 and over 1, up 1 and over 1. So it just goes off this way. And there's my piecewise function, and you get to see this break that happens here. In most cases, it should break. Try the different problems. If you need help, please ask. I know this was a longer video today, but these problems should go pretty quickly.